Hello guys, welcome to another video. I don't know which video this is, but explaining parallel and distributed computing unit 1. Okay, so let's get started. The idea of parallelism. So when you hear the word parallel, what do you remember? I would think something like a parallelogram or something as two lines that are, what do you say, with the same means two lines which go side by side that will never intersect each other. In mathematical meaning, when you draw another line which intersect both of them, then you'll the line between one of those line the angle between formed between the intersecting line and one of those parallel lines will be equal with the same one with the different, means the same the angle will be same as the line which is another parallel line which is also with the intersecting line. So that is parallel, something that will never intersect. Okay, in general terms we can say parallel as doing things simultaneously, doing them concurrently, meaning like one more very good example is in physics, where we say we have parallel and your sequential, no, not sequential, uh, okay, so you have parallel connecting, which is like you have two, like suppose resistors, you can connect them in series or in parallel. In series, that is one after another, but in parallel, side by side. This has its benefits and disbenefits. It decreases the workload in physics. Okay, it decreases how I can say the overall resistance between the two resistors. So that is parallelism. Again, you can also think of parallelogram, where the two opposite ends of the two opposite sides are always parallel, meaning that they have the same angle with relation to the base or one of those side adjacent sides. So that is parallel. Parallelism doesn't mean parallel like. Parallelism means it something that exhibits parallel. Okay, that something that is parallel but isn't exactly like parallel. So parallelism is something like mimicking, you can say. It's not exact, but it's like mimicking, I would say. Yeah, mimicking is a good word. So what exactly do you mean by parallelism? Is it just doing things faster, if you are asked? No, parallelism isn't just that. Okay, a consequences of parallelism is doing things fast, but it's not just doing things fast. How do you do a thing? And how do you do a thing? You have a task, you have a sequence of steps to complete it, and you'll do it. Okay, let's take with computers. You have a task, you'll have a sequence of instructions, you'll complete it. But if you're more capable, can you take another task? Like example, day to day humans, if I was part of the school debate team, I would not just throw my studies just to be on part of the school debate team, or in this context for me, I'm in college, so college debate team, I wouldn't throw away all my semesters just to be in college, because I have the capability to do both the college stuff and the debate stuff. Okay, so in that sense, I'm not exactly doing things faster. Okay, but in grand scheme of things, yes, I'm doing faster. When if I had to do both college as well as debate, then I would have waited for 4 years of college to complete then debate, or waited for like how many ever months to do did the debate thing then do college. No, but I'm doing them side by side. So in grand scheme of things, I am doing them faster. but because of the capability. If I didn't have capability, I would have chosen one or the other. Okay, it's all basis on capability. As computers became better, their capability increased. So if someone's capability increase and they have the ability to do things simultaneously, why wouldn't you just do that? This Like if you take those like for example, if those two tasks were actually related and were part of a bigger task, so doing them like side by side, like suppose you want to build a house, okay, um, doing both the plumbing as well as the electrical side by side, or paint tiling or with plumbing or something like that, it makes the overall thing, because this is like the task. As we come closer to the real world, we realize that tasks aren't just one thing, they are made up of many tasks. Means the task becomes so complex that a part of them can be subdivided into smaller tasks that in their own right are tasks themselves. So this parallelism allows us in like it doesn't exactly do things faster, but in grand scheme of things it helps do a larger task faster, because we are able to do subtasks simultaneously without wasting time. So we are reducing the time because of our own capability. That is parallelism. So it's based on capability. um, on basis of capability, you do either do parallelism for a task which is complex enough. If it is not complex enough, you not do parallelism. But if there's a task that is complex enough and you have the capability to do it parallelly, then a consequence of that is that you'll end up doing the task faster. And what is the benefit of doing things faster is that computation is expensive. Time, I would say, is the most expensive thing in the world. So you are able to save time, which you can use it for other stuff, which in grand scheme of things you can use it for another task. Okay, so this, like a task which is made of subtask, might be a subtask of some other task, and so on and so forth. So in this way, like in recursion, or like a building like a pyramid, you'll be able to do really highly complex tasks in much quicker. Okay. And that consequence will be that you'll have a better life, better experience, and better stuff. Okay. So how is parallelism different from multitasking? See, multitasking on a computer, as far as I know, uh, multitasking is the, like, it's focused based on humans. Okay. uh, Multitasking means that you'll switch from context to context. Okay, like suppose I'm listening to music while doing my homework. Okay, so there are times in multitasking where I'll be focused solely on my homework or focused solely on the music. Okay, I can sort of do my homework while listening to music, but my focus is on the music, right? But here in parallelism, the focus is divided. Okay, so the focus is completely on one task, at the same time completely on the other task. So this like machines aren't as I would say distraction error like humans. So when they are given a task, they'll do the task, so they don't have this thing like focus and stuff. So parallelism ensures that like the focus isn't that much deviated and the task end up completed. So instead of multitasking wherein the task is taking more time, okay, you will do multiple tasks, but sometimes the original task, the larger task will get delayed. Here the larger task as well as the smaller tasks are given equal importance, are done at the same time. Means they have no correlation with each other. In multitasking they have correlation with each other. Means in parallelism there is correlation, like based on resources, based on the computational time and stuff, but again it's based on scheduling and stuff. It's like but in parallelism it's, I would say, done with much more focus. Can you give a simple real life analogy before? Yeah, I gave a lot of real life analogies. But if I would say one more thing, it's like you're doing a group project, and you have to paint a pot. Okay, you have to make a pot and paint a pot. So if you don't know how to make a pot, you have to like first shape the pot on the potter's wheel as this clay. You have to make the clay, you have to shape it, then you have to bake it, then you have to paint it. So instead of a single guy making the furnace, instead of single guy bringing the mud, instead of like you need a special mud for it to stand and making the cart as well, you divide up the work. Okay, in this sense, the focus of the furnace guy isn't on what's going on with the other guy. Okay, with multitasking, that's the thing. With multitasking, the guy has to do same thing. Okay, so he will be building a furnace, and like suppose he's trying to make a blast furnace. So in that he wants the furnace itself to dry. So in that dry time, he will do some other task. Okay, but here the guy who's doing the furnace has sole focus on the furnace itself, no concern about the wheel or the mud. What do you say? Mud acquisition. So like, or else the guy would have built the potter's wheel, then waited it for to like get strengthened or something, bring mud, then wait for it to dry. Like it's like too much. Here the focus for this guy is on only on this guy is only on this guy is only on this. But what is focus for computers? See, in our computers we have something called a processor, right? A processor processes. That's, I won't go much deeper than it. So a processor can process. Okay, what if you like it takes a larger task and does it, like does its stuff? But what if you have multiple processors? So this process itself can become a part of a larger process. It just allows you to tap into higher complexities and stuff. So that's all there is. Okay, so like they say, a bunch of sticks together united, they will never break or something. Okay, does it parallel? Okay, power and potential of parallelism. What is the power and potential of parallelism? I would say power of parallelism is that you will be able to do much more complex tasks. Why? Because you're basically adding a new dimension. You're adding kind of depth and this thing to the task, which allows you to handle much more complex data, much more complex problems, and that is the power of parallelism. The potential of parallelism is that again dealing with complex problem, but also it allows you to in general allows you to have a better experience as a user. I don't know. Does parallelism always guarantee better performance or not exactly? I will tell. Like, see, if there's a task that is like computationally not very but very heavy but not very complex. Okay, if there's a complex task, okay, then parallelism will help. But if there is no complex task, like only one processor can do the task at time, but it's very computational heavy, it won't help at all. Doesn't always guarantee better performance. It's like studying for exams. Okay, one guy can study for what is this called? You have 5 exam and 5 friends studying the subjects. They thought that instead of like studying for all 5 subjects and getting mediocre marks, each friend will study one subject and help cheat other guys in the respective subject. So they divided up the work, divided up the subjects, and they all studied, they all cheated off each other, and they all got good marks. But here what if you had only one subject for exam and like only one topic very deep? Okay, so regardless of the other guy will study or not, okay, you have to study well. So that's the thing. Again, you can divide it up, but I'm telling, in real life it's full of complex problems. But there are times when these complex problems have to be kind of simplified for a computer to do its work, or else it's never simple enough for a computer, because you can always make it complex by dividing it up. So that's the thing. How much faster can programs actually get when we use parallelism? Is there like a limit? There's definitely a limit, because it's based on few things. Okay, How can you do parallelism again? Processors. So there's a limit on how much physically you can improve the processor, how much physically you can improve the computers. This is also based on how you use the processors. Okay, so you have bunch of workers who are excellent at their job. Okay, but if you don't manage them properly, they'll end up doing nothing. This is called job scheduling. This is called this is why management is so important. So if a guy he gives like four guys are there, five guys are there, he gives three guys different works but all involving the same resource. Like they have to make a car, they're very good technicians. Okay, they have to kind of make a car, but all five of them are waiting for one guy to make a structure of the car for them to measure and make stuff. Then it's those guys are waiting, wasting their time. You're wasting your time, you're paying them every time, you're wasting money, you're wasting resources. So instead what you'll do is that you'll say these guys, these are approximate what do you say, measurements. You can take this and kind of do the design work. However, you won't make the first wave only, you won't make the best thing. So you do your design, you do your prototyping in this stage. You give them like these opportunities, and then when the guy makes the chassis, you can pass on the chassis. Like one guy, he already took the measurements and the chassis is just waiting there. So you'll be like, you took the measurements, now you go away. So other guy will come and take measurements and do his stuff. So you can schedule. Like some guy, he needs to he has a like some important work, he needs to go early, while the other guy, he'll take so much time. So you say, wait, this guy, he has small work, he needs to go early, so you let him go, you tell this guy to wait, and you go. So everyone is happy, everyone is getting the work done, and it's just the process of scheduling again. But scheduling itself, there's a limit, but this limit is large enough for us not to be that much concerned about it. Why are computers shifting so much towards parallel processing? Because most of our real life problems are based on complexities, and real life is full of complexities, and modern computers needing to tackle them goes towards parallel processing. It's also more efficient, more effective. Explanation: sequential and parallel program. Sequential program is one after other. Like I do this work, next I'll do this work, next I'll do this work. But some like human, he might get tired out, but computer does not. But sometimes you can do works simultaneously based on your capability. Maybe earlier computers couldn't are very good sequentially, but now computers have enough processing power, because computers are made with the worst case in scenario, right? You're trying to play GTA 6 with max shaders and stuff. When you need to do multiprocessing, like opening multiple tabs, the processing power for that is being wasted here. So what you'll do is that you'll just use that thing. Yeah. Anyway, what's the next thing? Yeah, could you show an example of the same task written sequentially versus parallel? Same task written sequentially versus parallel. Suppose same thing. Let's take an example of making a pot, so from scratch. So one guy has to do the acquisition of mud, so he'll go to the river, get the mud. Next he needs to build the charka, the potter's wheel, so he'll go buy a charka, build it. Then he has to build a blast furnace, then he builds it, waits for it to hard. This guy, he's waiting there, he's doing nothing, but he's waiting there, he has no other choice, because he told, I'll do after this task, next I'll do after this task. It's very rigid. So it ends up happening that something that would have taken him 2 or 3 days to do, when he had a bunch of friends, will take him almost 2 months to do. So that's the difference, sequential versus parallel. What kind of problems are naturally sequential and hard to parallelize? Problems that are I would say not very complex, but were very large. That's I would say. When I look at parallel programs, how do I know they're efficient or just complicated? How do I know they're efficient or based on how much the work is being divided up, but also the adaptability of the system. I'm going to go fast. Scopes and issues of parallel and distributed computing. What's the difference between parallel and distributed computing? Are they the same? Distributed computing, yeah, you're kind of right. But distributed computing, you're distributing the work within a larger system. Okay, you're giving him the work to do that work on his own, regardless. Parallel is kind of, it's based on how much relation with each other system. Parallel is a closer relation, sequential is the closest relation, distributed is a much more farther relation. It's like completely regardless of what's happening to other. Sometimes his task doesn't even concern what's going on with others. What kind of problems show up and when we try to split up tasks? The problem is that like sometimes when we split up tasks to merge those tasks again, there's a problem. Why? Because there might not be exact fit, there might be sometimes waste of time, there might sometimes it might be too much for a single guy to handle if you don't manage properly and stuff like that. And who takes in charge? Like if there are four leaders and among them they're dividing up the work, who is the actual guy in charge, who takes the hard calls? So you can do it like each guy does his own shit, or one guy based on seniority and experience he's the main guy or something. Does parallel computing always require expensive hardware? Can we do? We can do it based on the capability of the system and how we are processing it. Just that, how we are managing it. Is the goal of parallelism to make computer run faster, or are there any goals? It's like to help increase its scope to more complex problems. Can parallelism reduce the energy consumption? Yeah, it does reduce energy consumption by doing it faster, by doing it more efficiently, but sometimes it might take more energy because of the merging and splitting up tasks. That itself is a task, no, so it takes more sometimes. Other situation where parallelism, yeah, exactly, I told, like sometimes where it's not as complex but you make it complex yourself. Instead of doing straightforward simple techniques, you try to do this that, so you make it worse. Parallelism and concurrency using multiple instruction streams. What is the difference between parallel and concurrency? People used to interchangeably. Parallelism, I told you, is not exactly like parallel, but like parallel like. Okay, to a outside guy, it seems like parallel like, uh, like like doing one task, then parallelly doing another task, but not in between of each other. Means like not side by side, but like after this task completes somewhat, then you do this task somewhat, then do this task somewhat, then do this task somewhat, then do this task. Concurrency is like I'm gonna do this task along with this task together. That is concurrency. Um, how does multiple instruction stream execute actually? So the multiple instruction streams are being divided up and then given to each processor who does its stuff. Is concurrency always implemented within parallelism, or can it exist in a single code too? Yes, it can exist in single code too, based on again processing and how you are able to software do your software. That's all I would say. How much time did it take? 23 minutes. Okay, I did not say explain that well, but for now it's good enough, I guess. Thank you. Goodbye.